Hello, welcome to the launch of the Virtual HTAP Summit. My name is Michael Lin. I'm a solution engineer at PingCAP, and I'll be your host today. We have some exciting speakers and content for you. You hear about a new breed of databases known as NewSQL and how companies are using it in the real world. I can't wait to get it started for you. First, I'd like to introduce our speakers today. We have Ed Huang, who is the co-founder and CTO of PingCAP. He's a pioneer in building cloud-native systems and is in love in building distributed systems. He's also well-known in the open source community as a contributor. He's an entrepreneur with the hacker soul. We have our speaker as well, guest speaker, Ashwin Karuhatty. He's with Cloud Database Partnership at Google. He has 20 years of experience building strategic partnerships and is focused on cloud and mobile computing platforms. He's laser focused on enabling technology that drive customer experience and business impact. Now, a quick agenda for today's opening for the HTAP Summit. We'll have Ed, our CTO, give a quick talk on HTAP and serverless, followed by a fireside chat between Ed Huang and Ashwin, with discussing the current trends in big data systems in the future. So without further ado, I'd like to turn over the time to Ed Huang, our CTO.
Okay, thank you, Michael. I will share my screen. Okay, thank you. Have this opportunity to give the quick introduction and sharing about my thinking about the future of database. If you're familiar with me, I do the opening in every year's TiDB user conference. So the title is all the same, the future of database. So today I also want to use the same title. Yeah. First of all, I want to bring up the question about who actually made the decision for the enterprise, for the company, which database they are going to use. So this is the survey result, and you can see the database technology most of the time is chosen by the architects, developers, DBA. I would say most of the CEO, they basically don't care which database they are going to use. But from the user's perspective, from the database user's perspective, I think the actual developers matter. So actually, I think the direction for today's topic is about how we are think about the application developer, how we can make a what kind of make a database that the application developer really matter, really want. And so with this question, I will share some big trend about the database industry. The first big trend is the cloud is basically eating every software. That's why we have our good partner Google Cloud today. So as we can see, that's the big trend that cloud will be the king. The second is that also let's take a look at the database market. As you can see, the cloud database is growing so fast, and in this survey result in last year, basically the cloud database and the on-prem database is about 50-15 market share in the database revenue. So I would say in this year, maybe in next few years, the cloud database will according to this trend, will bypass the on-prem database market. So yeah, I think the answer is obvious, is very obvious. The cloud database will be the future, but everyone today we're talking about cloud talking about database, but let's take a deeper look. That's what actually, what's slowing down the application developer. They are building their application. What's slowing down their slowing down them to create value. So from the data technology perspective, I also want to share some survey result. So take a look at this result. Basically, most of the time, the application developer dealing with database, they are spending their time on maintaining the database, on like updates, setting up, cleaning, like backup, restore, and also monitoring. So actually, the time they spend on building application only near 39% in this survey result, and most of the time they are spending time on maintaining the infrastructure. So another interesting proof is that A16Z is a very famous VC firm in Silicon Valley. In 2020, they released the so-called unified data architecture. It's a big map, basically putting all the mainstream data technology into this map. So it's pretty huge and very ambitious. So that's why I call it unified data infrastructure 2.0. But to me, as an engineer, as an application developer, the first impression to me on this diagram is it is so complicated. If I'm running for example, if I run in the small business, or for example, like I'm going to build an e-commerce, building the ordering system for the coffee shop. So I don't have the enough expertise to maintain all of this infrastructure. And you can see every small box in this diagram, and it is a kind of the data technology database. And you have to dealing with how to moving the data around, moving the data to different box. That's super complicated. Yeah. So here is a real world example. Actually, last few months we have built a very interesting demo. It is called OSS Insight, which is a small tool that just collecting all the GitHub's data and real-time GitHub, using the real-time event API published by GitHub, and do the real-time analytics and get some insights from the open source world. But imagine that if you want to build this the application, the data service application like this in the old day, you have to use different kind of data technology. Like for example, for your production database, you have to maybe use Postgres or MySQL, and when the data becoming bigger and bigger, you have to use some middleware or sharding proxy on top of the relational database. And then because like we want to get some insights from this data, so you need to move the data to another data warehouse or other big data processing system. So that means you have to create the ETL, the pipeline system, and basically you may use Spark, Flink, or some kind of the big data tools, and then getting doing the data processing, and you have to backfill to the production database, or the like the key value cache like Redis to serve the online traffic, to provide the online application. So this pipeline is to me is a little bit complicated. Can we do more? Can we do better? Can we make this architecture simpler? And so to me, I think that today, from the application developer's perspective, the big trend is more and more engineers are focusing on the front end, focusing on the API, and the infrastructure part. Today is too complicated. So I think that's reasonable that application developer focusing on the front end, the web, the API, because I think today's database vendor, database technology expose too much complexity to the application developer. For example, when you want to deploy a database on cloud, you have carefully choose the VM instance. You have to carefully calculate this, do the sizing, do the pricing. So it is too complicated. So how to make it simpler to application developer? So our answer is to get a higher abstraction of database. So that means I will give a very straightforward example to show what is the abstraction. So let's think about in the old days, like 10 years ago. At that time, we don't have the cloud is not very popular at that time. So all the application developer, if you want to build an application, basically you have to focusing on the infrastructure, like hosting the VM, hosting the machine, hosting the actual physical servers, and then the cloud becoming more and more popular, and the cloud vendor abstracted the physical node to VM. They are maintaining the virtual machine and provide and provide packing them and provide the VM service interface to the application developer. So the developer, they don't need to care about care about the physical machine, physical nodes. So it is higher abstraction, and that means the faster speed to go to market for the application developer. And then we have Kubernetes, we have container, and the people they don't even need to worry about the VM. So it is more closer to this abstraction layer is more closer to the actual application. So after container, what's next? So I put the question mark here. I will share my answer in that next few slides. The second is the same methodology if we apply to the database technology. So in the old days, the lowest abstraction level is, for example, if you want to deploy use a database in 10 years ago, basically you have to deploy the database by yourself. That means you have to focusing on the infrastructure provided by cloud or data center. You have to buy the physical nodes and tuning the operating system to make the database running fast. And then more and more database vendor think, hey, it's too complicated to the application developer. So they build better database, like putting the high availability, the distributed transaction, HTAP, and geo-partition, all these good feature into the database kernel. So for the user, when they want to use a distributed, want to use a database at a large scale, they don't need to worry about the details about how the database distributed the data. So that's higher abstraction from the database kernel level. And recent few years, and we are going further, we think today more and more database or data technology vendor are going to provide the cloud service. They are not only building the software, they are not only building the database kernel, they actually building the service. So putting more and more ease of use and doing higher abstraction for the database service, like multi-tenancy, and putting the data migration, backup, restore as a service, so that the application developer, they don't need to maintain the backup and restore by themselves. And like PingCAP, we are putting the system diagnose using some AI technology to help the application developer to automatically tune their database. That's and we make it as a service. So the higher abstraction level, the easier the application developer can use to use this database to build their application. So what's the next level of abstraction? So today, our answer is, I think that the big trend for the database technology is serverless. I think my answer is serverless. Another important thing is HTAP, hybrid transactional analytical processing. So these two combining together will bring the new kind of database experience. I will from the user's perspective, this kind of database will be first blazing fast, lunchtime blazing fast, and you don't need to worry about the configuration. And yeah, so basically just like if you want to launch a new database instance, all you need is just like click a button and wait a few seconds, or maybe wait for few million seconds that the instance will be there. The second thing is that the serverless is not only focusing on a small amount of data, but that can scale. So when your business or your data growing bigger and bigger, and your workload becoming bigger and bigger, the system will scale as you need. And another beautiful thing is that when you don't have any workload, this system will scale to zero. They will not charge you anything. So that's very important to the serverless product. So that should be scaled to zero. The third is about HTAP. So nowadays application, the application nowadays, sometimes we cannot distinguish whether it is an OLTP workload or OLAP workload. So I would say more and more data analytics workload require the real-time capability. So I think that's reasonable to provide some one-stop solution for some ad hoc OLAP query directly on your production database to reduce the complexity that's introduced by moving the data around. So basically, if you can use one database to solve your problem, why use two, right? So the next point is the pay as you go at the finer granularity. That's important. I think that's a little bit related to the scale to zero thing. And the last but not the least, I think it is ignored by a lot of database vendor or infrastructure vendor, but getting more and more attention this year is the integration, the better and deeper integration with the modern application development process. For example, how this database can integrate with your CI/CD platform, how this database can integrate of your everyday, integrate with your IDE, integrate with your modern CL, the everyday platform you are using, like Vercel, like other systems. So yeah, is super. Can this database provide some example code to help application developer to build the application faster? So that's the kind of things that from users perspective, what does it mean for the serverless HTAP database? So the question mark is even possible. So today I'm announcing we actually built the first prototype of TiDB serverless. We just launched a few weeks ago, and this is a small demo. We show that just like I said, the serverless database that requires a fast launching time. So as you can see in this demo, I wrote a small program to launch a new TiDB instance just in 24 seconds. And another beautiful thing is that all of this capability we expose via Open API. So that means that can easily integrate with your everyday life in the from the developer perspective. So from the under the hood, basically the philosophy of building such database, I want to only mention one thing is the key to building this kind of system is how we can leverage the cloud, the service provided by the cloud. We are not going to reinvent the wheel, but we want to use as more as possible about the cloud service. So this is the architecture diagram of this new system. So this is the plan we are going to do for TiDB serverless version. From the user's perspective, as you can see, the in the near future, we will, for example, currently the serverless tier for TiDB reduced about 80% of the cost, and next few months we will make this number to only 5% of the cost of current deployment. So to the customer, from the customer perspective, that will be a huge cost saving if you're using the serverless TiDB. On the other hand, the launch time a few months ago is like 15 minutes to launch a new cluster. Currently, just like I showed, the demo is 24 seconds, and the next few months we will shorten this this time into 5 seconds. So yeah, that's our target. Okay, let's imagine a little bit further. For example, what's the world gonna be like in the future? The serverless plus HTAP that really lower the burden, mental burden for application developer when they are going to use database. So to me, that creates a new developer experience, frictionless developer experience. Like in the early days, we have distributed SQL. We can make this system, support auto failover, high availability, transaction, and we add the HTAP capability that can serve both our TP workload and our AP workload at the same time, and you don't need to worry about the the OLAP will interfere with the performance of OLTP side. So, and then the serverless application developer don't need to care about the configuration, deployment, and also can leverage these cool features using the open API. So all this capability getting together that will create the frictionless developer experience, like I said. Yeah. And another, from the technology perspective, fully leveraging the cloud storage, the cloud infrastructure will unlock some interesting, business model, like data sharing. For example, today, the new engine of the cloud, the serverless TiDB, all of the data is stored in the object store provided by the cloud vendor. So to us, that it is possible that we can have the possibility to create some data sharing feature in the future that will create, I think, a large, serverless data sharing market. So there is the trend gonna be like 20 years ago, we only have the traditional RDBMS market, basically the vendor is selling software. And currently, nowadays, all the database company are becoming the cloud database company providing service charged by the service. And in the future, I think the serverless database market will more focusing on the API to help the application developer to create value faster, and also provide some like data market to to share the data easily. So that's the future gonna be like in my eye. So this is the last page. This is our version. We want to bring the simplicity to the developer by building the better database to let the developer and the builders focusing on what really matters, which is application. Okay, this is my sharing, and the serverless TiDB is there, so you can just have a try, tidb.club. Okay, thank you.
Thank you, Ed. Appreciate that. With that introduction, I'd like to open the fireside chat with Ashwin and Ed. And so I'm going to throw some questions at you, and feel free to either of them, both of you, to answer it. So, all right, here's the first question. What is the hottest trend in big data systems?
Ashwin?
Sure, I can go first. Hey, everyone. Thank you for being part of the summit. My name is Ashwin Karuhatty. I'm the global lead for cloud database partnerships at Google. And TiDB is one of the partners that we manage. So thank you for the question. And Ed, great presentation. Loved kind of some of the insights that you shared about how databases are evolving from relational to cloud databases to serverless, and very much in line with how we look at kind of the data market. What I would like to say is, like, look, I mean, if you look at any one of the Google events over the last 12 months, you will recognize that data is the most important way to transform any company's business, and is a fundamental ingredient, not only in driving competitive differentiation, but also delivering innovative new services. Ed kind of talked about it, data plus API. What companies are looking at today, they're basically asking different questions about their business. They're looking at not only just optimizing their business processes, but they're also trying to figure out, how do customers interact, understanding the needs of their end partners, understanding and getting their workforce to engage effectively across this ecosystem. They're asking more from their data. And as a result, there's new technology approaches that liberate them to focus on what matters. And what we've done at Google is we've looked at this holistically as a cloud-based data platform strategy, which can not only turn complex data systems into value, but also integrate industry-leading AI and ML, which is what kind of Ed was talking about, right? Data plus API, data and AI. It's kind of the future, and that's where everything is going. And what we're doing is we're trying to bring that all together into a unified data cloud, all built on a trusted foundation of reliability, scale, and increased security. So that's the kind of focus that we have in terms of our unified data cloud strategy. Very much in line with what Ed was kind of talking about. Ed, I would love to hear your thoughts as well on where you see this going.
Yeah, cool. Thank you, Ashwin. In my mind, I think the big trend is that in the early days, the data technology only focusing on the infrastructure or focusing on the very detailed technology. But I think in the future, the vendor will more and more focusing on the user experience, developer experience. So that's why everything we're going to everyone wants a unified platform to solve the problem. I think that's the big trend, and we're more focusing on the end user experience, make it more easy to use. That's the trend I would see. Yeah.
Awesome. Thank you for that. All right, here's the next question. So what's your thought on the adoption of distributed databases as data grows exponentially?
Ed, do you want to go first?
Yeah, I can go first. Like 7 years ago, when I decided to create a PingCAP, I actually got a huge inspired by Google's banner. I think that's the future of database. So yeah, today we build a partnership with Google Cloud. That's an honor to me. So I think the first thing is that the distributed will be the future. In the future, every database will be the distributed database. And no, like before PingCAP, I was in charge of the database infrastructure for a large internet company, and at that time we don't have the distributed SQL, we don't have like Spanner, we don't have TiDB, things like this. The only option for us to solve the scalability problem is that at that time we use a lot of MySQL, but MySQL, it just doesn't scale. So if you want to solve the scalability problem of the single good old MySQL, you have build a lot of middlewares or do the manual sharding. That's super painful. So I think the distributed SQL database that basically save save us a lot of time to help the developer application developer to build their application more easily. They don't need to worry about the sharding. They are not after sharded the traditional database, you cannot use the SQL in the old day. But to me, the SQL is still the most important programming interface to the application developer. So I don't like NoSQL because NoSQL API is very simple. If you want to build a complicated application, you cannot use sometimes using the NoSQL interface is really hard to build complicated application. So SQL is still the king, and the distributed SQL, I think that's the that's the kind of like a must for the future big data applications.
Yeah, no, I would agree. I think, as you said, look, I think what organizations are trying to get done is having access to the right data and the timely data at the right level at the right time to everybody in the organization. And for that, distributed data systems are super important. A lot of time today is spent on just managing data and building reports, but not necessarily enough time spent in finding new ways to analyze and making decisions that really matter to the end user. And as kind of outlined earlier, where you go from a relational database to a cloud native database to now a distributed database, that allows for organizations to drive decisions at the lowest level where it really matters. I think just to kind of highlight some of these points, there was an Accenture study done a couple of years ago where they talk about kind of the data value gap, right? And what they say is, well, the data and AI space is a multi-trillion-dollar industry today. Only 32% of companies are able to realize the value of data across their increased data silos. And that becomes a challenge, right? It's so fragmented. Most of the organizations are unable to unify the way they centrally manage, govern, secure, and access their data. And distributed systems make those kinds of things very easy, especially with API-driven and AI-driven world. So I would say more and more organizations are looking at not only just managing their data, but analyzing their data. So we see a lot of this OLTP plus OLAP coming together, and especially with TiDB and the HTAP kind of scenario, it becomes a perfect fit for not only just this high throughput transactions that are going through, but also analyzing that data in real time. Sorry, I just dropped my bottle.
All right. Okay, I'm gonna jump around the questions a little bit with some of the latest things in AI that have been floating around the net and LinkedIn. So what do you think about ChatGPT and its potential impact on cloud data, search, infrastructure, and software development?
It's interesting, ChatGPT. I'm just been following that. They got 1 million. Was that 1 million users in 3 days or something like that?
Yeah, something crazy. Yeah,
crazy. I spent most of my time recently playing around it.
It's a little bit scary when you look at kind of like the AI-driven chatbot services and what that AI kind of comes back with on some of these things. But look, I think it is absolutely obvious that data and AI go hand in hand. And if you look at kind of any one of the Google database products and things that we are talking about, Vertex AI is a great example wherein we're building in the AI capabilities into the data management platform to enable unified data and AI solutions, right? Not only managing and deriving insights from every stage of the data lifecycle, whether it's databases, data warehouses, data lakes, streaming data, AI and ML data. How do you bring all of these together to give necessary insights? And AI is a critical part of it. And if you haven't used Vertex AI, I really encourage everybody to kind of look at Vertex AI, and along with the kind of the GCP kind of dependability around speed, scale, scalability, and security. I think it brings in what our customers need today around data and AI and managing that in a very seamless way.
Cool.
And I'm still yet to get like ChatGPT. I'm trying to get access across the board to a number of folks. But I think the point is ChatGPT is a good example of how data and AI kind of come together. But there's still a lot of work to be done for that AI to be meaningful, to be accurate, to be delivering what the user wants. Yeah,
agree. Totally agree. Actually, to me, in the early days, in the like before ChatGPT, I I'm the infrastructure engineer, like hardcore engineer. Sometimes I think AI is just like buzzword, right? It's super hot, but how to use that. But recently, I feel that it actually becoming useful. Yeah. So the first impression that amazing. For example, like I talk to the AI, hey, help me tuning this SQL. I wrote the SQL. Can you give me the better version of of this? And for example, I gave the table schema, the SQL table schema, and asked the AI, hey, can you bring me some interesting questions about this table? he actually gives some very reasonable answers to me, and I get the insights. So I'm thinking that makes me really believe the future. Just like Ashwin said, the data and AI coming together. So yeah, I think that this direction is really promising. Yeah.
And it'll only get better, right? Like, look, majority of the AI models, like we have to train the AI models,
Yeah.
right? And there's a lot of these data input that needs to go into these AI models to kind of get a better understanding of the scenarios and all of the things. So over the course of the next few years, I see data and AI becoming integral and going hand in hand, especially around distributed databases, right? I mean, as we train these AI models into the data, the results of the AI models will get better and more insightful and more decision-making kind of criteria.
Yeah. Maybe in the future, I will provide some, database for AI workload. Maybe we should put some resource on that. Yeah.
Yeah, it's pretty amazing. I think, things like auto tuning of SQL queries that are coming through database systems, and then how to reconfigure the database structure, your cluster for you based on the traffic patterns. I mean, those are pretty amazing things that we could do as a developer, right? So yeah, I'm pretty excited about, the future of combining databases and AI and ChatGPT and Stable Diffusion. Pretty amazing stuff.
Hey, Michael, if there's no other questions, I was going to answer one of the questions that was on the chat.
Yeah. Feel free.
What's the advantage and disadvantage of third-party databases like TiDB versus AWS GCP native databases like Schema and Aurora? Right? Great question, right? I don't necessarily talk about kind of how AWS does their stuff, but within GCP, like there's most of our third-party databases, we look at it and say like, hey, look, they're doing some very innovative stuff, very meaningful stuff, very kind of focused effort on specific things like HTAP and OLTP and OLAP. And we treat majority of our database partners as kind of equal citizens across our first-party databases. So if you look at kind of Spanner or Bigtable or any one of the Google databases, all of the third-party databases, whether it's TiDB or MongoDB or DataStax or Neo4j, the way they get treated is first party versus not necessarily first party versus third party. They're all equal, right? If you look at the Google console, you can go in and kind of single click launch any of these database partners. So I would say in majority of the engagements that we do with our customers, it's the customers dictate what's best for them. And we look at it that way and say like, hey, how do we solve the customer problem? Whether it's Spanner or TiDB, does not matter, as long as the customer is solving the problem. So we rely on customers to dictate what works best for them, and we don't differentiate between our first party and third party databases in any kind of these engagements.
Yeah, no, that's awesome.
That's awesome. That's awesome. Yeah. Yeah, I think the Google Cloud treat every partner or third party database vendor equal. That's the best thing I have heard. Yeah. Thank you.
All right. Let's see. I want to leave a little time to see if there are any questions for the attendees. I haven't seen anything come through yet, but you still have a chance.
I think there's a question which Ed, you might want to answer that. Data storage, yeah.
Yeah, I think you can go first. I can answer it on database side. Yeah.
Yeah, no, okay. I think from a platform standpoint, look, security, governance, data integrity, those are all super important. Especially governance is becoming more and more important as we look at kind of Europe and any one of the data sovereignty issues that is coming up. So from a platform standpoint, we do everything that we can to not only conform to the sovereignty requirements, but also ensure that the data is secure and data is managed and only accessible to certain the relevant parties. So that's more from a platform standpoint, from a GCP platform. But also, I know partners have very specific requirements that they will be going through around these things. So, and I know, like TiDB and how TiDB manages security would be important to kind of help the audience understand.
Yeah. Actually, to us, I think the first thing is the compliance, like SOC 2, GDPR, and we're using this. We pass all of this the compliance and as the first thing, so people can feel safe. And second, from the technology perspective, we heavily relying on the security capability provided by the cloud itself. So basically, don't trust us, trust Google Cloud. So it is the philosophy we are following. So in the security part, we integrate deeply with our cloud partner. Yeah, so that's the strategy. Yeah.
Okay, I see one more question. What is the main benefit of HTAP versus OLTP plus CDC plus OLAP? Is it mostly the real-time analytics queries?
Okay, I think Michael, you can answer this question.
Seriously?
Yeah.
All right. Well, the nice thing about this is, it's all set up for you, right? And the data as are inserted into the system and created in your databases, that data is automatically updated and made available through our HTAP columnar storage, which is the TiFlash engine. And what that really means is you don't have to worry about, doing ETLs, writing queries to take data from your transactional system and pushing it over to your analytical system. And so the developers don't have to, write those things, and you don't have to maintain those synchronization scripts. And at the same time, what's even better is the data is available as soon as it's inserted into your transactional load, right? You don't have to wait for that time, whether it's hours or minutes or days before it comes to the OLTP side. So that's the real pretty awesome aspect of it, is that as soon as the data is available on the transactional side, it's available also on the columnar store analytical side.
Okay, I will add some comment on that. The HTAP architecture is not going to solve all the problem. There is no silver bullet. For example, in some use case, you still need to do the ETL, you still need to do the data transformation. So, and for example, and sometimes you don't need the, you still need the data warehouse for some really heavy, heavy OLAP query. So I would say the HTAP architecture is really good for some lightweight OLAP or ad hoc OLAP. You don't need to do the actual ETL. But when you think, hey, we still need to do the pre-aggregation or doing the ETL, and I think still using the CDC and another database warehouse is still a good idea. So yeah, that's the comment about Michael's answer. Yeah.
All right. Thank you very much. Are there any other questions? Last chance. All right. Well, one just popped in last minute. Let's see. What is your opinion of multi-master? Is it a very desirable feature in HTAP? It may be difficult to be implemented in serverless.
Wow, that's the very technical question. I can answer that. The interesting story about how we build TiDB serverless and HTAP is, just like I said, in the early days, we inspired by Google Spanner. Google Spanner is a share nothing multi-master distributed system. And another fancy thing is that the Spanner is an OLTP system. So TiDB followed that path. So first we build a 100% scalable multi-master OLTP database. And then we extend the capability for TiDB to do some analytical workload by adding the columnar extension to the OLTP data. So that's the that's the path how we build the HTAP system. So that really very difficult, but I think the most difficult part is building the scalable OLTP system, and we have passed that that step. So it's not really hard. And make it serverless is another story. I think the key to build a serverless database is that how you can leverage the, like S3 or, like computing, elastic computing service provided by the cloud vendor. So we heavily leverage the Kubernetes and block storage published by Google Cloud and other cloud vendor. So that's the key of building serverless. Yeah. That's yeah. How Michael, you
Thank you. Yeah, thank you very much, Ed and Ashwin, for hosting our opening of the HTAP Summit. I'd like to tell our attendees that we have the availability and launch of a bunch of exciting content and video content on the website that you sign up with. If you scroll down to the bottom, it's shown on the screen right now. There are a lot of content that happened in our physical HTAP Summit, where we recorded the different sessions for different of our customers that came in and talk about their usage of TiDB and what their experiences are. So feel free to scroll down and listen to. It's on demand. You can watch any video that's on the website. You just need to make sure you log in and come back to watch whatever content you need to. And also, we have some trivias that you can earn points on if you answer them, and you can have an opportunity to earn some cool prizes. And last but not least, I'd like to, here the prices shown there, the prizes. And then last but not least, I'd like to let everybody know that on a regular basis, we'll be releasing additional content on HTAP and its development. So keep attuned as into our channel, and thank you very much for attending. Appreciate it. It was an awesome event, and thank you again to Ed and Ashwin for hosting and being our guest speakers.
Thank you, everyone.
Thank you, everyone.
Thank you. Bye-bye.
Bye.
Bye.